Hello, ladies and gentlemen. Welcome back. Chapter 2.2. This is part 1 or day 1. Now, what we're going to do today is we're going to expand a little bit on that normal curve and the percentiles. All right. So this is going to be a little bit more than what we did in advanced algebra. Okay. I kind of call today a go backwards day, and you'll see why when we get there. First of all, let's make sure we understand percentiles. For example, if I said I am in the 78th percentile for my height, okay, 78th percentile, that means I am taller than 78% of the people, all right? So my area to the left of whatever that is would be 0.78. Obviously, I'm on the right side of 0 on that normal curve, okay? So I'm taller than 78% of people, but that also tells me that I am 22% or 0.22 shorter than people, all right? Let's keep going here. The 50th percentile, you already know. Okay, that one's automatic, ladies and gentlemen. Okay, 50th percentile, you would be right smack dab in the middle. Okay, that's where the 0 is, remember. So 0.50 to the left, 0.50 to the right. Now, let's say that you're shorter than normal. So let's say you are in the 35th percentile. Okay, well, that means you're on the left side of the normal curve. Okay, you're over here, so 0.35. Again, 0 is in the middle. So obviously your z-score there, when we get to it, would be a negative. All right, so that means 65% or 0.65 would be taller than you. All right, and then let's say that you are in the, let's say, the 95th percentile. Okay, well then you're way over here, folks. Okay, if you score in the 95th percentile on your SAT or ACT, that means you did better than 95% of everybody, and that means 0.05 did better than you. All right, okay, now it's going to be our job in this section to be able to go backwards and use that information when we use our z-score. Remember, z equals x minus the mean divided by the standard deviation. Now, what we're going to do is we're going to be given a percentile and we're going to find the z-score. All right, it's real easy, and we're going to strictly use the calculator for this, so you have to use the calculator. It's called inverse norm. Remember the power of pause and rewind if I go too fast, folks. Okay, you can always pause, you can always rewind. Now, I'm going to do that first one, the 78th percentile. Okay, so I'm going to go inverse norm 0.78. The calculator can only find the z-score of something to the left. Okay, so whatever decimal or area is to the left of this spot, so we're going to find this z-score right here. That's what we're going to find. It's to the left of that. All right, so this is what we do. We pull up our calculator. You go second vars. Again, second vars, it's number 3, inverse norm. You put your area in there, 0.78. Okay, leave the mean as 0 and the standard deviation as 1 and paste it in and then hit enter. So we're going to round 2 decimal places. So the z-score is 0.77. So when I look at my normal curve, this z-score is 0.77. Now, please don't get the percentile and the z-score mixed up. Okay, you might think that sounds funny, but every year I have students who for some reason never get it that they are two separate things, and obviously they don't do well on the AP test. All right, well, the 50th percentile, you already know. You don't need to use inverse norm for that. It's 0. Okay, but let's look at 30.35. Let's look at this one. What would this z-score be right here at 0.35? So we're going to go inverse norm, 0.35. Okay, again, the calculator can only find the area to the left of that. All right, so again, second vars, number 3, 0.35. And we're going to round it to negative 0.39. Negative 0.39. So the z-score is negative 0.39. Okay, z-score, z-score. All right, so this is negative 0.39 for your z-score. All right, and then the 95%. So again, I would go, let me switch colors here. I would go inverse norm, 0.95. Second vars, number 3. You could do this with the table, folks, but the calculator is so much easier. We don't even need to go to the table. Okay, we're always going to use our calculator. So 1.64 is the z value for 95%. 1.64. So this is 1.64. All right, now let's start applying this knowledge to situations. Here we go. Let's say you are in the 78th percentile for a test you took in a freshman college course. Let us also say there are 500 students that take this particular course. Question number 1, how many students did you do better than? Okay, well, we don't need the normal curve to answer this question. All right, you are in the 78th percentile. That means you did better than 78% of the students. So the decimal, always work with the decimal, it's 0.78. So I'm simply going to take 0.78 times 500. Okay, we did do this in advanced algebra. Okay, this was part of it. Okay, a minor part of it. So take your 0.78 times 500. Okay, instead of me pulling up the calculator, I'm just going to use my handheld one here. So 0.78 times 500, and that's going to give us 390 students. So you did better than 390 students. Okay, cool. All right, how many students did better than you? Okay, well, there's 2 ways you could approach that. You could either take 0.22, because 22% did better than you, times 500. Or you could simply go, okay, 500 minus 390, and I believe that's going to be 110. So you have 2 ways to approach that one. All right. Now, the next one. Again, remember you have the power of pause and rewind if I'm going too fast. Now we're going to get into some real algebra, okay? So here we go. So 95% of the students scored between 63 and 87. Okay, folks, I need to visualize that. So I'm going to do this. All right, I know 0 is in the middle, and 1, 2 below, 1, 2 above, 3 below, 3 above. Okay, so 95%. Well, I know, ladies and gentlemen, that this, did I go far enough? I believe so. This is 95% according to our little diagram. Okay, see right here, 63 to 87. Okay, that's 2 below to 2 above. Now that's the standard normal. Okay, it's already been standardized. So this is 63 to 87. Now it says estimate the standard deviation for the scores on this test. Okay, you can't use 2 below to 2 above, okay, because that's the standardized. That's not what the actual standard deviation is for this situation. So remember, we're going to use z equals x minus the mean divided by the standard deviation. But it wants to know, what is the standard deviation? Well, that tells me I got to know my z-score. I have an x, I have to know the mean. Well, wait a minute, they didn't tell me the mean. Well, think about it, ladies and gentlemen. The mean is going to be right here where the 0 is, right? Okay, so the mean, we're simply going to take the 63, which is 2 below, the 87, which is 2 above. So we're simply going to add those together. Okay, and then we're going to divide by 2. Okay, so our mean is going to be 75. So we were able to figure that out. So this is 75. All right, now, what about the z value? Okay, ladies and gentlemen, that's what I just got done teaching you with the inverse norm. Well, if this is 95%, that means this is 2.5% to the left here, and it's 2.5% over here. Okay, think through it. 95% is in the center, 2.5 is to the left, 2.5 is to the right. The decimal for this is 0.025. Okay? Now we don't necessarily need to use that, but I'm going to. Okay? Let's use it. Let me take that statement back. Let's use that. Okay? We're going to take the inverse norm now of the 0.025. So what I'm going to do is I'm going to use this piece of information to find my standard deviation. Again, rewind if you need to and listen to that again. All right, so I'm going to go ahead and put this into the calculator now. Here we go. So I'm going to go to my inverse norm. So second vars, number 3, 0.025. So I'm going to use that 63 and the z-score for this to find it. All right, so I'm going to round it. That's negative 1.96. That's my z-score. Okay, that's not my standard deviation. That's my z-score. All right, so negative 1.96. Now, if you really, really want to, ladies and gentlemen, you could just use the -2. Okay, there's some give and take, minor give and take here when you solve these. You could just use -2 if you want, but I'm going to be more accurate and I'm going to use the negative 1.96. Okay, so that's my z value, folks. Okay, so here we go. We're going to find the standard deviation. We know the z-score equals, I'm going to use the 63 as my x minus the mean, which I found to be 75, over the standard deviation. Okay, right now I'm just going to use S as my standard deviation, because remember that is for a sample standard deviation. Okay, I'm going to use my algebra now to find this answer. So I've got negative 1.96 equals, all right, 63 minus 75, I believe that is negative 12, right? Okay, I'm going to solve for S. This is all algebra. I'm going to solve for S. So S is going to equal negative 12 divided by negative 1.96. Okay, I hope you know what I did there. I multiplied both sides by S and I divided both sides by negative 1.96. All right, so now I'm going to go ahead and I'm going to type this in and see what we get. So we got negative 12 divided by negative 1.96, and we end up with 6. We're going to say, let's just round it to 6. Okay, so the standard deviation is approximately 6. Okay, so the standard deviation is approximately 6. So what is your score on this test? Wow, okay. You are in the 78th percentile, right? So the inverse norm for 78%, let's go back to page 1. Okay, come on, there we go. The z-score for 78th percentile is 0.77. That's my z-score. So I'm going to go 0.77 equals x. That's your score. We don't know it. Minus the mean, which we figured out was 75 because that was halfway in between, divided by, oh, we found the standard deviation from part C. Folks, this is how the AP test could be. You have to do parts A, B, C to help you with part D, okay? That's the way it is, all right? And we're going to put a 6 there. All right, now we're going to use algebra to solve this, okay? So what I'm going to do is I'm going to just draw a little loop, folks, okay? This is, it takes 2 steps to solve it, but I usually draw a little loop, and this is what we do. We multiply, and then we're going to add the mean. So I'm going to take the 6, just here, I'll do it on here. So I'm going to take the 6, the standard deviation, times the z-score, and then I'm going to add the mean. Go backwards. So your score is approximately, oh, we'll round it, approximately 80, because I don't think you're going to get part of a point. So your score is approximately 80 points. So use the curvy line for approximate. All right, so that's what you scored. All right, let's look at it again with this situation. In another class that you are taking, 12% scored better than you. Oh, 12% scored better than you. 12% scored better than you. So that means you scored better than 88%. Remember, that's what we have to use. So I'm going to use my inverse norm to find my z-score. All right. So I'm going to do my inverse norm of 0.88. And that's 1.17. Always go 2 decimal places. Always. Okay. So again, that was 1.17. So that is your z-score. So I'm going to take 1.17, I'm going to set it equal to x, because we don't know what your score is. Oh wait, the average in the class is 82. Oh, it does. Okay, hold on. I was thinking it was a different problem here for a second. The class average is 82, so that's going to go behind the minus sign. You scored an 88, so 88. And we want to know the standard deviation. Okay, so it's just like that other problem we did. We have to go backwards and we have to find the standard deviation. So let's see, that's 1.17 equals, let's see, that would be 6 divided by s. All right, now I'm doing algebra. I would rewrite this as s equals 6 divided by 1.17. So the standard deviation for that one, let's see, 6 divided by 1.17. So it's approximately 5. So the standard deviation is approximately 5. All right, let's keep rolling here. We're already at about 20 minutes. So in this situation, the Army reports that the distribution of head circumference among male soldiers is approximately normal, with a mean of 22.8 inches and a standard deviation of 1.1 inches. Use the 68, 95, 99.7 rule to answer the following questions. Show your method. All right, so what I'm going to do, ladies and gentlemen, is I am going to mark my mean right here. Okay, and I'm not going to standardize this one. I'm going to use this picture to help me. Okay, I'm going to use that picture to help me. So the mean is 22.8. Now, 1 above, 2 above, 3 above. 1 below, 2 below, 3 below. All right, so my standard deviation is 1.1. So I'm going to add 1.1 each time I go up on that normal curve. So here we go. I'm going to add 1.1. So one standard deviation above is 23.9. Okay, the next one is 25. And then the next one is 26.1. Okay, now I'm going to subtract going to the left. So 1 below is 21.7. 2 below is 20.6, and 3 below is, it looks like 19.5. Okay. All right. So a male soldier whose head circumference is 23.9 would be at what percentile? Okay, folks, well, that's one above, right? So looking at my table here, let me fix this because it did something weird. There we go. Okay, looking at one above, that would be all of this, right? So I figured that out, and that would be approximately 84%. If I add all of those up, don't forget there's a little bit in this tail and a little bit in that tail. Okay, which doesn't show up on this picture. So that's going to be approximately 84%. The decimal is 0.84, but change it to a percent, it's about 84%. And that was just using that picture. All right, let's keep going here. All right, so what percent of soldiers had head circumferences between 19.5 and 23.9? Well, 19.5 is 3 below to 23.9, which is 1 above. All right, well, again, you can use this picture, ladies and gentlemen, and you simply can go 3 below to 1 above. So you're just going to take those and you're going to add them together, right? Okay, and again, you're going to end up with approximately 84%. Okay, I think it's more like 83.85. I think that's the more accurate one. Okay, but again, it's approximately 84%. All right, moving on. The graduate record examinations are widely used to help predict the performance of applicants to graduate schools. The range of possible scores on the GRE is 200 to 900. The psychology department at a university finds that the scores of its applicants on the quantitative GRE are approximately normal with mean of 544 and a standard deviation of 103. Okay, use table A or the calculator to find the proportion of applicants whose scores X satisfy 500 to 700 as part of your answer. Draw the normal curve and shade the area. Okay, folks, I'm going to save a little bit of time here because I'm already at almost 24 minutes and I still have at least maybe 10 minutes to go here. So if you need to take a break and then come back to it. Okay, you cannot skip any of these notes. They're all way too important, especially the last 10 minutes because we're going to get into the formal we're starting to get into the formal statistics and it gets very, very picky. And if you don't follow it, you're going to get penalized, not by only me, but by College Board also. All right, but anyway, I'm going to save a little time here. I've already found the z-scores. Okay, so I'm just going to very quickly write this. Okay, there's one z-score for the 500. Now I need to find the other one. All right, now I'm going to mark those. I'm just approximating them. Okay, now I'm going to use the Normalcdf, ladies and gentlemen. Now, warning, never ever write calculator notation on my test or the College Board test. Never write that. You can have it in your notes, but never write what I just wrote on a test, any test. Okay, that's a big no-no. Okay, it's for you only. So, but I'm writing it here for your notes. So remember, we're going to go from negative 0.43 to 1.51. Second vars, number 2. Remember, we never use number 1. So the lower is the negative 0.43. The upper is the 1.51. Get used to using the calculator. Don't be stubborn and say I don't want to, because it won't be good for you. All right, so that's about 60, 0.60. All right, so 0.60, which is 60%. All right, well, let's keep going. Again, power a pause and rewind if you need to. So what we do, ladies and gentlemen, we have to start writing sentence answers when it's a free response. Approximately 60% of the applicants to graduate school will score between 500 and 700 on the GRE. Start getting used to writing complete sentence answers. All right? Okay, moving on. What minimum score would a student need in order to score better than 77% of those taking the test? So, okay, so again, 77% is going to be over here somewhere, because you're scoring better than 77%, right? So this is where we have to use that inverse norm. All right, so let's pull that up. Let's do that quick. Okay, it's going to obviously be really, really close to that 78 we did earlier. Okay, so I'm going to round it 0.74. All right, so we're going to go ahead and we're going to go 0.74 equals, we want to know what is your score, X. The mean is 544 from up above, and the standard deviation is 103. So we're going to go ahead and do this little loop. All right, I'm going to go backwards, but I'm going to do it this way. So I'm going to take 103 times the 0.74, and I'm going to add 544. Go backwards. Okay, and so your score is 620. Now there's a decimal on that, but they're not going to give that to you, so we round it. So 620 is your score. Okay. Ooh, almost forgot about that. When this happens, ladies and gentlemen, we actually always want to round up. Okay, we break the rounding rules here. So when we're finding that value, we want to round up. So we're going to say your score. I don't think they would take points off if you said 620, and I don't think I would take points off either, but the rule is supposed to be no matter what, you round up. So a student would need to score 621 on the test in order to score better than 71% of those taking the test. Because actually, if you go to 620, I see where they're going here. If you go to 620, that means you've dropped below the 77%. So just to be on the safe side, you want to round up. All right, got to keep going here. So if you need a break, pause it, come back to this later. Okay, but you must watch this next part and think through it very carefully because we're getting into the formal stuff. Here we go. So this is in your book, ladies and gentlemen. Again, my expectations are that you are reading the book. Okay, as a college course, the professor would expect you to read the book. We were talking the other day, other math teachers, how some professors, they would give a lecture, you take all of these notes, and they would tell you to read something, and then they would give you the test. And the test was all on the book, nothing on their lecture. And then the next test, it would be all on the lecture and nothing on the book. So you got to be ready for everything, okay? So what are we going? Formal statistics. There are steps involved. Solving problems involving normal distributions. Step 1, state the problem in terms of the observed variable x. Draw a picture of the distribution and shade the area. Again, this is in the book, and I'm doing the example out of the book. So if you turn to, I'm on page 142 if you want to follow along. Page 142. Okay. Step 2, standardize and draw the picture. Standardize x to restate the problem in terms of the standard normal variable z. Draw a picture to show the area of interest under the normal curve. Step 3, use the table or calculator, use the calculator. Find the required area under the standard normal curve using the table or the calculator and the fact that the total area under the curve is 1. 4, write your conclusion. All right, moving on. Here's the problem. Again, it's right out of your book. The level of cholesterol in the body is important because high cholesterol levels in a large population of people of the same age and sex is roughly normal. For 14-year-old boys, the mean, mu, is 170 milligrams per deciliter of blood, and the standard deviation is 30 milligrams per deciliter. Now notice, ladies and gentlemen, they're using the parameter mean, the population mean, parameter mean, and standard deviation because it's talking about all of the boys, okay? It's not a sample, it's talking about all of them. Levels above 240 milligrams may require medical attention. What percent of 14-year-old boys have more than 240 milligrams of cholesterol? All right, step 1, here it is. Again, this is in your book. This is on page 143. Let x, so this is what you got to do for a problem, okay? No complaining and whining. Let x equal the level of cholesterol in the blood. X has I talked about this in the last video, that means normal distribution with mean of 170 and standard deviation of 30. And what do we want to find? We want to know the proportion of boys with cholesterol level of X greater than 240. Step 2. Okay, we draw the curve. Okay, we draw the picture. Okay, and you can see the picture on page 143. I'm not going to take time to do that because it's right in front of you on page 143. Draw that normal curve. Step 3, use the table. So we see that the proportion of observations less than, this will be on, you got to turn the page to page 144. All right. So we see that the proportion of observations less than, let's see if I can, less than 2.33 is 0.9901. About 99% of the boys have cholesterol levels less than 240. The area to the right of 2.33 is therefore 1 minus the 0.9901. That's if you're using the table. You can find this answer without using the table. You could use the calculator. So this sentence right here that I'm going to underline in red, this sentence right here could be ignored if you used your calculator with the normal CDF. And that will be 0.0099. Okay, so this is about 0.01 or 1%. Okay, So let me just demonstrate with the calculator really quick. Okay, so with the calculator, actually I'll write it out for you instead of me typing it in. So if you use the calculator, you're doing the normal CDF, you would put in the 2.33, comma, and then a really large number, and that's going to give you the 0.0099. Actually, let me type it in and see what it does give us. So second vars, we've got the 2.33, that is our lower limit. The upper limit is just a big number. I'm going to pick 100, and I'm going to see what this calculator, yep, 0.0099. So that sentence I underlined in red could be ignored. All right. So the conclusion, and then the video is over with. Okay, I know it's a little long, it's going on 40 minutes. Write your answer in context of the problem. So about 1% of 14-year-old boys have dangerously high cholesterol. So we end it with our conclusion. All right, 4 steps. Look at the other examples in your book. Look at that example again, study it. Okay, so from here on out, when we do on a test, if I have that type of question, those are the steps you have to go through. All right, good luck, ladies and gentlemen. We'll see you later.